Okay, so in this video, we'll be looking at powers and roots of complex numbers. I will have my camera on, but my dog is up above on the desk. So if you hear any barking, I apologize. So let's get started. So if we let Z and W be complex numbers, then we'll say that W is an nth root of Z if W raised to the n power equals to Z. Okay. W to the nth power is Z. Okay. So that's what we call the root of a complex number. All right. So the derivation is to figure out the roots would be the following. If we let W equal to rho times cosine phi plus I times sine phi, and then Z is equal to R times cosine theta plus I sine theta, then W to the N equals to Z implies this relationship by Dumoiv's formula. Rho to the n times cosine of n theta plus I times sine of n phi, excuse me. Rho to the n times cosine of n phi plus I times sine of n phi is equal to R times cosine theta plus I times sine theta. Now we'll have this relationship here. Rho is equal to R is equal to rho to the n, and then phi is equal to theta is equal to n times phi. But the problem is if we add on 2 pi to theta, we would get the same result for theta equals n phi. So in general, for any integer k, theta plus 2 pi k is equal to n times phi. And then we will use this relationship here to solve for phi. Okay. And so we would have that rho is equal to r raised to the 1 over n, and then phi is equal to theta plus 2 pi k over n, right? And then in general, we would have this formula right here to figure out the roots of the complex number Z. So roots of Z would be right there, right? R raised to the 1 over n times cosine of theta plus 2 pi k over n plus I times sine of theta plus 2 pi k over n, where k ranges from 0, 1, 2, on up to n minus 1. Okay. If k equals n, we'll have the same exact root as we started with at k equals 0. Okay. So for example, if I want to compute all three roots of the complex number minus 1 plus 3i, well, z is 1 plus root 3i. So that means it's in the second quadrant. So here's the real axis and the imaginary axis is here. So it would be this complex number z here, right? And I'll write this out in vector form, minus 1 root 3 here, okay? And so the first thing we want to do is figure out the radius. In this case, r is equal to the square root of minus 1 squared plus square root of 3 squared, which should be 2, right? R is 2. Theta, on the other hand, so theta, we want to figure out the principal argument, right? The principal argument of z. So what would that be? So the principal argument is minus pi to pi. So what that means is the principal argument in this case would be 2 pi over 3. Okay. Um, yeah, so yeah, it will be 2 pi over 3. Okay. So to figure out the roots of the complex number minus 1 plus 3i, all three roots, this would equal to 1/3 power times cosine of 2 pi over 3 plus 2 pi k over 3 plus I times sine of 2 pi over 3 plus 2 pi k divided by 3. Let me chop this this bracket here. Where k equals 0, 1, and then 2. Okay. So so when k is 0, we would have one root as so I'll call this call this W1, I'll say. W1, this is 2 to the 1/3 power. So when k is 0, we would have cosine of pi over 3. I'm sorry, 2 pi over 9. Plus I times sine of 2 pi over 9, right? And then when k equals 1, we'll have W2 is equal to the radius to the 1/3 power times cosine of, so that is 2 pi over 3 plus 2 pi, 6 pi over 3, so 8 pi over 9. So 8 pi over 9 plus I times sine of 8 pi divided by 9, okay? And when k is 2, we will have that W3 is equal to 2 to the 1/3 power times cosine of 2 pi over 3 plus 4 pi. So that is 12 pi over 3. So that is cosine of so 6 should be 14 pi over 9. Okay, so 6 pi. Okay. Yeah, so that's 4 pi, 12 pi over 3. Yeah. 14 pi over 9. Doesn't hurt to double check. Sorry, and sorry being so hesitant. So yeah, so these right here would be the 3 roots of the complex number -1 plus 3i and plus root 3i, excuse me. It's root 3i. Okay. So it's pretty straightforward. And then I'll go over the topology of the complex of the complex plane, the topology of the complex plane. That'll come up soon. But for now, I want you to work on these comprehension problems. Okay. Comprehension problems. This is let me look at the page number. Page 24 to 25. Forgot the page number. 2, 6, 8, 15, 17, 19, 27. Okay. So those are the problems for you to work with. And then next time we will go over the topology of the complex plane. So that will constitute on learning about open sets, closed sets, connected sets, and looking at how to draw various sets in the complex plane. So I will see you all in the next video. Thanks for watching.